Hi everybody, welcome to the second video in our series focusing on paper 2 maths exam. And in this series, we're particularly looking at the DBE 2023 paper. And so question 3 covers analytical geometry and all of the things that go with it, like lines which are parallel and perpendicular, the formula of a straight line, midpoints, distance, angles, and so on. So let's jump into it. Remember, if you want to follow along with us, you can either download the exam paper and try it yourself before going through the answers with me, or you can look at the questions in the video as well. Okay, so here in the figure, you've got L, which is -4 and 1, S, which is 4 and 5, and N, which is -2 and -3. And these are the corners of a triangle which has an angle of SLN, which is 90 degrees. Then it says LN intersects the x-axis at K. So LN is K is over there. All right. So it says calculate the length of SL and leave your answer in third form. So this is simply a distance calculation or a distance question that they're asking you for. And so we need to write down our distance formula. So our distance formula says the square root of x2 minus x1 squared plus the coordinate y2, y1 squared. All right, and so we're simply going to substitute in our values. Now we know S was given to us at 4 and 5, and L is given as -4 and 1. So we're just going to put these values in. Okay, so let's start with L as -4. And what I like to do is just fill in the first coordinates. I find it less confusing. Put in my minuses and then fill in the second coordinate. So S is just 4 and 5. That way, if we need to do a sign change or anything, we can do it straight away without causing confusion. All right, and then we just simply simplify. So this will be -8 squared is 64. This will be -4 squared, which is 16. And so our answer that we get, if we plug it into the calculator as well, will just be 4 square root 5. If you add 64 and 16, you get 80. So the square root of 80. You can also just put this part into the calculator as well. So let me just show you that quickly, just so you've got an idea. All right, so we're going to say square root of -4 minus 4 squared plus it was 1 minus 5 squared equals, and it gives us 4 square root 5. Now, it's a good idea as we're going through this video just to make a note of these answers. I have my own little answer sheet, just so that, because a lot of the questions follow along. So you've really got to follow that. Okay. So the next question says, calculate the gradient of Sn. And if we go back and look, the gradient is this section here, and that's 4 and 5, and N is -2 and -3. So if we grab a pen, gradient formula we know is the change in y, in other words, y2 minus y1, over the change in x, which is x2 minus x1. All right. So if we start with S first, we're going to have 4 over 5 minus, and N, which is, sorry, I've written them in the wrong place here. See, it's very important to pay attention here. So your S, your X is 4, which is at the bottom, and your Y is 5. And then for N, your Y is -3, so it'll become +3. And your N, your X is -2, so it'll become +2. There we go. So that gives us 5 plus 3 is 8, and 4 plus 2 is 6. And if we simplify that, we get 4 over 3. Okay, and we simplify simply by dividing the top and the bottom by 2. All right, so that's that. Then our next question says, calculate the size of theta, the angle of inclination of Sn. And so we've already found the gradient. We know the gradient is 4 over 3. And to find the angle of inclination, we know we just use tan. So we have tan theta is equal to our gradient, right? And we just substitute in what we know. It's 4/3. And then very quickly we grab our calculator. And we're going to say second function tan, because we're finding the inverse, 4/3. And that gives us an angle of 53,13. So that would be our answer for this question. So your marks here would be the formula tan theta is equal to 4/3, and then the actual solution, which is 53,13. All right, the next question says, calculate the size of angle LNS. Okay, so what I did for this, actually, let's just go back quickly and look. LNS is this angle here. All right, so what we can see is if we put this section here in a Cartesian plane, this here is flat, and so this is also 53 degrees. And so we're looking for the remainder of the angle, which is this. So if I find this angle, I can then subtract the 53, and I will have my middle angle, which is what we're going to do now. Okay, so now that we know what to do, let's go and do it. Okay, so our first step is to find the gradient of Ln. And again, we know simply that the gradients of Ln, I label the gradients simply so that I know when I refer back to previous questions and I'm looking for something, that I know which gradient is which. So it's just to help me figure out where I am in the exam, and I find it a very helpful technique as well. All right, so Ln, we know L is -4 and 1, so 1 at the top, -4 at the bottom, minus. N is -2, -3, so -3 and -2. And so what we've got at the top is 4 over -2, and so our gradient is -2. From that, we substitute into tan theta. Very handy little thing, this. Okay, so we know tan theta is equal to -2. Okay, now remember, because it's on the cast diagram as so, tan is negative here, so we're going to have it as 180, whatever our reference angle is. Okay, so we chuck that into the calculator. I'm not going to pull it up now because I don't want to lose all of this working out, but basically we'll get that theta is, or theta, or tan, or the inverse of tan theta is equal to -2, or -2 would give us 63. So what we're going to have is 180 degrees minus, because we're over here in this quadrant, 63, 43 degrees. And so our answer for theta, or let's make it alpha, because otherwise we're going to confuse ourselves, alpha. So our answer for alpha would actually be 116,57 degrees. But this is not what they've asked us for. They've asked us for LNS. So we need to now calculate the final angle, and LNS is found by taking alpha and subtracting theta. And so we have 116,57 minus 53. Remember, we found theta in the previous question, 13 degrees is equal to 63,44 degrees. All right, and so there's quite a few marks here, and I'll just go through them. So the first mark is to find your gradient of Ln. The second mark is to find this angle here. Okay, and the third mark is to find your actual question or a solution to your question. So you can see if you follow your working out, you should get all of your marks. Okay. The next question says, determine the equation of the line which passes through L and is parallel to Sn. Write your answer in the form y is equal to mx plus c. Okay, so firstly, we know the gradient of Sn. We found it in question 3.2, and that is 4/3. And so we can just quickly substitute that in. Y is equal to 4/3 x plus c. Now, the only value we're missing is c, and it says it passes through the point L, and we know L is -4 and 1, right? So we're going to substitute this point in. So we've got 1 is equal to 4 over 3 times negative 4 plus c, and we're looking for c, so it becomes 1 plus 4 times negative 4 is negative 16 over 3, and then we bring it to the other side, becomes plus 16 over 3 is equal to c. So our c value is 19 over 3. Now, have we answered the question? No, because they've asked it for it in the form y is equal to mx plus c. So we write, therefore, y is equal to 4 over 3x plus 19 over 3. Okay, so marks here again, substitution of your gradient and your coordinate points. Your gradient is a mark, and then, of course, your final line equation is a mark. Okay, so quite nice and straightforward, not too complicated. Question 3.6 says, calculate the area of triangle LSN. So if we go back and look, we're looking for this entire triangle, and we can see that this is a perpendicular base and a perpendicular height, or however you like it. So when we want to find the area, we know that the area of a triangle is equal to half base times perpendicular height. Okay, we've already found the length of SL, so we only need to find the length of LN. Okay, so the first thing that we need to do is find the base, the LN. Okay, so let me just make this LN so we know. So it's square root x2 minus. It's always good to write down your formula, as it helps with substitution and checking back. Y2 minus y1 squared. All right, so here we've got L is negative 4 and y is 1, and n is minus, n is 2, so that becomes plus, and minus 3, so that becomes plus. So this becomes minus 2 squared is 4, and this becomes 4 squared, which is 16. So we have the square root of 20, and if we put that into the calculator, it simplifies to 2 square root 5. Now, that is all 1 mark. Okay. Now we need to actually substitute that into the area formula. So area is equal to half times our base we now found is 2 square root 5, and our perpendicular height is 4 times square root 5. Okay, so half times 2 is 1 times 4 is 4, and square root 5 times square root 5 is just 5, and so we have 20 units squared. Okay, so you'll have a mark for substituting in your entire formula, and then another mark for the 20 units squared, which to give us the 3 different marks. Okie dokie. The next question says, calculate the coordinates of the point P, which is equidistant from L, S, and N. Okay, so if we look here, P is somewhere on this diagram, and it is exactly the same distance from all of these points, okay? Which means that we can use the distance formula to find them. All right, so what we then have is we know that LP is equal to SP is equal to NP. Okay, and so we're going to use the distance formula. So I'm going to use LP is equal to SP, and of course we're just going to make the fact that P we don't actually know, so we're going to make it A and B, and we're going to solve for those coordinates. Okay, so if we think about the distance formula, it's a square root is equal to another square root, so we can just drop the square roots because they are the same, and we just look at the inner part of the distance formula. So L is negative 4 and 1, so it's going to be negative 4 minus a squared plus 1 minus b squared is equal to, and now we're going to use s, which is 4 and 5. So it's going to be 4 minus a squared plus and 5 minus b squared. Okay. If we simplify this, negative 4 squared is 16. Negative 4 times negative a is positive 4a times 2 is 8a. And negative a squared is positive a squared, right? Then we have on the side 1 squared is 1. 1 times negative b is negative b times 2 is negative 2b. And b squared. Okay. And on this side, again, 4 squared is 16. 4 times negative a is negative 4a times 2 is negative 8. So I actually need to erase that plus and make it a minus 8a and a squared. Okay, and then this one here is 25 minus 10b plus b squared. Okay, now we can see the a squareds and the b squareds are on both sides of the equation, and a squared equal to a squared cancels out. Okay, and b squareds cancel, because if you take it to the other side, it becomes b squared minus b squared and a squared minus a squared. All right, so after some manipulation, which I'm not going to show you here, your final equation will look like this. It'll look like this. 16a is equal to 24 minus 8b. And if I simplify that further by dividing by 16, I get 3 over 2 minus a half b. Okay, and we call this equation 1. All right. So please write that down, because I'm going to erase this and do part 2, okay? Okay. You can pause the video here and just write it down so that you've got it. I'm going to clear now. Then what we've got for part 2 is we're going to use the L part again, LP. So the negative for a, being an R here. Minus a squared, 1 minus b squared is equal to, and this time we'll use NP. So we'll have negative 2 negative a squared plus negative 3 negative b squared. And again, on this side, we'll have exactly the same as we did before. Okay, and on this side, we'll have negative 2 squared is 4. Negative 2 times negative a is plus 2a times 2 is plus 4a. And a negative a squared is positive a squared. Okay, and then negative 3 squared is 9. And negative 3 times negative b is negative 3b times 2 is positive 6b. And negative b squared is b squared. Okay, and again, you cancel out the a's, and you're simply going to be left with this 4a. I'm skipping a couple of steps here just to make the video shorter, but you should try and work through all of it and make sure that your answer is correct. Is negative 4 plus 8b. And if we simplify here, we get a is equal to negative 1 plus 2b. And so this is equation 2. Okay. So what you get a mark for is finding those two equations. That's the first mark. All right. So write this down again. And then what we're going to do is we're going to make equation 1 and equation 2 equal to each other. So we'll have 3 over 2 minus a half b is equal to negative 1 plus 2b. Okay, because they're both equal to a. And then this is from paper 1, so solving simultaneously, and now we're just going to find the value of b. So we're going to have 3 over 2 plus 1 is equal to 2b plus a half b. Okay, and so what we get here is 5 over 2 is equal to 5 over 2b. And so we can see from this that b is equal to 1. And now when we substitute this back into a, I'm not going to do the fraction one because fractions. But both of those, either equation 1 or equation 2, if we substitute in the b value of 1, what we should get is a is equal to 1. Okay, and so that is your final answer. So you'll get a mark for B here and a mark for A here. Now, there are other ways in which to solve this, and I'm not going to go through them now. I'm just going to talk about it briefly because I do think it's important to know that if we are thinking about geometry, okay, we can see that if we consider this a quadrilateral cyclic quad, right, then this here, if these points Sn and L lie on the circle, then Sn would be your diameter and L would be on the circumference of the circle, right? And so the midpoint of Sn would actually be the center of your circle. And if we work out the midpoint, which is 4 minus 2 is 2, divided by 2 is 1, and 5 minus 3, which is 2, divided by 2 is 1, then it gives us exactly the same answers we found using the other method. But sometimes we don't always see, particularly myself, I'm not a huge Euclidean geometry fan. I don't always see those. And so I default to algebra. Both methods are correct. It's just how you find it. So if Euclidean geometry works for you, then definitely use that method. But if algebra is more your happy place, then use algebra instead. Okay. The final question of question 3 is to calculate the size of angle LPS. All right. And so to do that, let's look back at our LPS is this angle here. Okay, and again, if we're thinking about geometry and we're thinking about this as the midpoint, we would think of, let's just draw some lines here. So if P is here, right, somewhere there, we have LPS is this. So we're looking for this angle here. Okay, and if I draw a little Cartesian plane, we can see here that this angle and this angle are both theta. All right, and so because it's alternating angles, this straight line here is parallel to the x-axis. Okay, so then this would be 180 minus 53,13, which would give us an angle of 126 degrees, which is the solution. Okay, and then you can also use angle at center is double the angle at circumference. So there are various ways in which to calculate it. Again, go and take a look at the memo. And find the solution that works best for you. You know, the saying, there's many ways to skin a cat, absolutely true in maths. All right. Guys, thank you so much for watching video 2 with us about question 3. We hope that you found it helpful and informative and that it will help you succeed in your maths exam. Remember to join us for our next video, which is looking at question 4, also all about analytical geometry and the center of a circle when it is not the origin. Remember to take a look at our website, maths@sharp.co.za, for those free worksheets, study guides, etc., etc. Have a super day and we'll see you soon.